Okay, hello, this is tutorial 1, problem 2. Problem 2 is a simple shear and moment axial force diagram, and it should be pretty straightforward, so I'm not going to go into too much detail here. I'm just going to cover the important points. First off, when you're doing this problem, you have, let me make sure everything's in frame. Okay, you have, keep in mind that this whole length is not L. This length is 2L, which means because your W is given in terms of P over L, this total omega is going to equal 2P. I don't want anyone getting tricked by that. You have sine, you have 30 degrees. So this is 1, this is square root of 3, this is 2p. Remember that this is a pin, so of course only pins can carry this axial load. So axial load may seem kind of weird to draw, because you normally just care about moment and shear, but it's really just straightforward. You have no axial load here, right? Like if you have this P here, and you have this reaction here, let's call this R1x, then these two will perfectly cancel each other out. You'll have nothing here, so your thing will just look like this. It'll go up here and it'll go all the way over here, and it'll be constant because you have no change in your axial load. Shear. There were a few questions on how to draw shear, and yeah, I don't really know like a good way of explaining. I'll just show you how I do it, I guess. I look at this and I see, oh, this is pointed downwards, so it must be driving my shear down. The reactions, I assume, are pointed upwards, so they must be driving my shear up. So in this case, because omega is pointed downward, like I have a negative slope here. I'm not going to give you the exact diagram here because I want you to calculate these things, because this is very important. You're going to be doing shear moment diagrams a lot this semester. I don't know how cruel Professor Letchford would be, but for my junior year, my equivalent class, we had to do 100 shear and moment diagrams. And this was basically extra credit. But he gave us Thanksgiving break to do this. If we needed extra credit, he assigned it to us the day before Thanksgiving break, and he gave it to us. So I don't know if Professor Letcher is going to do something like that. I don't think he's quite as cruel as my teacher was. But anyway, just keep in mind that your shear, it doesn't have to be continuous. Your shear is not going to be continuous here because you have reactions and you have point loads. But this omega just gives you a negative slope, and wherever you have a discontinuity, it's just going to be a jump. So you have a reaction here, let's say it goes up here, and you have the same slope. It just keeps going down. You have another thing, and it goes down. And I drew this wrong. I should have drawn this up high over here. And then where you have this force acting here, it's pointed downwards, so you have another discontinuity there. It's pretty straightforward. The only other point I want to tell you is for your moments, don't actually worry about calculating the moment directly. All you need to do is draw the general shape. Professor uses positive going downward, and that's actually very useful. As you said, it gives you the deformed shape. But if you have trouble with this is good. But if you're having trouble with this, then draw it upwards first and then reverse it later or something. Make sure you get this. Make sure you get this right. But yeah, just draw the general shape. You don't need to make it super precise. As long as you have the shape, and then give me the moments, or give us the moments at your maximums or minimums. These are pretty much all you need, and you don't usually worry about. You're either usually told like find the moment at x equals like 5 or something. So you come over here and you find the moment. Like sure, you can do that, but you usually don't compute the exact shape directly. You just want the general idea, and you want a few key points on the way. Some tricks to remember sign conventions. I don't know about you. I learned that this moment was positive, and the way I remember this, the way I was taught, was that it positive moments are a happy moment. It's a very happy moment. Yay! Although those look more like braces than teeth, but it's a very happy moment. The tension, you can kind of remember the tension is positive because tension, what does this look like? It looks like a plus sign. That's the easiest way of remembering it. And then I don't really know a good thing for shear. But shear, just remember clockwise. And I guess, oh yeah, the way to remember this is that when you draw these together, when you draw moment and shear together, it looks like a circle, right? You're just going around in a circle. But I don't want you to get confused with this. Yeah, this is just general sign conventions. The moment and shear diagram, it's very important that you know how to get this right, but unfortunately I don't know where the difficulty is going to lie, so I can't go into too much detail here. If you have any problems, come see one of us, because this is extremely important. You are going to use this a lot. Yeah, especially this semester. I think, assuming it's anything like my semester was, you're going to be trying a lot of these. Anyway, yeah, come see us if you need any help.